Now we have Matevz from Oasis. Thank you very much.
Hey, hey. Right, so in the next 30 minutes, I'm doing a crash course on Sapphire. And for those of you, there's a recording of the session I had a week ago. There's a one-hour course, which ended up being 75 minutes long. And it's about it's a workshop on how to build dApps on the Oasis Sapphire. But I ran out of time the last week for concrete hands-on Solidity hacking for confidential smart contracts. So I thought of doing this in the next 30 minutes. Hackers got this. So this is the Oasis cheat sheet, basically. And I would just go through the most relevant parts and then spend most of the time on the Solidity code, and just to get your hands dirty on and see how things work in practice. Best programming practices, put it this way. Okay, so the first QR code here is the Demostar project, and this is the project we suggest everyone to use. It's nothing particularly special. So I already mentioned this a week ago. Basically, it is, it's a monorepo written in TypeScript. You have two components, the backend one and the frontend one, and the smart contract is stored in the backend one. The frontend one is a Vue-based frontend app, and the backend one is the one that we'll be focusing today. And I already checked it out here in my home folder, and we will use this IDE to hack on it. Okay, so there were questions about whether I should use Ethers or Web3 or Veeam, WAGMI, whatever. So Web3 is obsolete, as you probably know, so don't use that. We prefer to use Hardhat and Ethers combination. WAGMI 1 already works out of the box. WAGMI 2, we had a huge 5,000 diff PR ready to be merged in, and it's not in yet. So we prefer to use TypeScript Hardhat combination. For the front end, use either WAGMI 1.0 or just an ordinary Ethers connector. Okay. So this is the Demostar project. Let's move on. The next link here is a bunch of examples. So this is the so-called playground. And that currently there are 13 projects. There's, again, a bunch of projects on my to-do I'd like to add. But basically here, just to briefly go through, for example, if you click on, let's say, confidential voting, here there are these tags here, and they show you which technology and what are the highlight features that you should be focusing on. So this one, for example, uses gasless. This means that the user who votes concretely in this confidential voting dApp example, they don't need to pay for any gas fees, and we will also show, see in the examples at the end of this talk how this can be done, in practice. But the idea is that you don't require that your users have an Ethereum or whichever network ETH-compatible wallet, that they don't need funds to pay for the gas fee, right? So if you imagine there's an election, government elections, whatever, and you have your voters wanting to submit their poll, they just go there and they put in the ballot, right, in a box. They don't need to have any tokens whatsoever to pay for the fee. So that's the ideal scenario, and that's what this example is about. Right. So here, for example, you have interesting things. The authentication authn example takes the basically the mobile devices have this authn protocol integrated, which you can use to authenticate yourself to whichever service out there. So this is just one. Maybe there's a team doing biometric stuff. These are the examples they should look at. What else? There are some examples which are strictly CLI. So for example, this one. They have this CLI tag. So basically it's just a backend example. Okay, and some more. For example, Oasis Swag. This was one of our favorites. Basically, it uses the on-chain random number generator. There's this wheel of fortune, and then you get a reward. For example, the Oasis hat on this screenshot. And let's see, what do they use? So it's a React-based front end. The Oasis Swag is an NFT thing, so you can also then transfer it to your wallet, random number generator. And it was presented at Consensus 2023 and STC 2023 conferences. So yeah, and you can of course filter by a specific tag, search for it, also the license, type of sources, does it contain demo code, is it part of the official documentation, and so on. Okay, let's move on. The testnet faucet. So anyone deploying their dApp on our testnet will need the token, and we are very we are not conservative about that. So you just go here, you pick your layer, so either the consensus layer or any of the popular chains below. You will use Sapphire, most of you, so the confidential EVM compatible chain, and just type in the address. Let's go ahead and I will have this one. I'm not a robot, I hope. So yeah, CAPTCHA. And yeah, cool. And I should suppose that should work. Sooner or later, yeah, it's a Sapphire testnet. Okay, so this is a testnet faucet. I will not wait, it should work. If it doesn't work, ping me on Discord. It does, yeah. Awesome. Then the documentation. So the most important part for you is probably dApp development, since you're a developer. So create dApp and Sapphire. Again, the landing page for the Sapphire chapter is the chain information, the chain ID. So these are information needed if you want to basically connect to it with your client, backend, frontend, whatever. There are multiple RPC endpoints, since we are decentralized, of course. And to register Sapphire to your MetaMask, you don't need to enter those information manually. Just click on the button, for example, here. And if your network is not registered yet, the MetaMask pop-up will show and add it to your config. Oh, yeah, tokens arrived. Cool. Next, the block explorer and the wallet. So we have the official Oasis block explorer. It's at explorer.oasis.io. The main difference between our explorer and the other explorers are that our explorer is not only EVM compatible, but also covers consensus. So this is still a work in progress, but it will be there soon. And also, you will notice these icons here for transactions. The gray icons mean that the transaction was not encrypted. The green icon means that the transaction used the native end-to-end Oasis-powered encryption. Why am I talking this? Well, because you can also have an unencrypted transaction, an ordinary Ethereum transaction with the call data as they are. But inside the call data, you can simply, encrypt the content with a shared key on-chain, for example. And the transaction will be shown as an unencrypted transaction. But actually, if you try to look into the transaction content, you would see just some binary blob, basically. So yeah, this is the Explorer. you will notice typically you just search for some hash. I don't have any of those here. Or no, let's search for this account. Okay, and if you look up, okay, you may notice that there is an account on Sapphire mainnet, but there's one more result, and it's also on testnet. So my account actually is on testnet. I think I used it once on the mainnet by accident. Yeah, it's half a rows there. You can transfer it. I have the private key here. So yeah, the point being, the same Explorer covers both testnet and mainnet. Okay, so you just enter the thing you're looking for here, and both results will show up from the mainnet and the testnet. Okay, Oasis Wallet. A very similar story. So you can use MetaMask on Oasis Sapphire because Sapphire is EVM compatible. There's also another chain called Emerald. This is an older chain which doesn't support confidentiality. And both are EVM compatible. That means that you can use MetaMask or any other Ethereum compatible wallet to transfer tokens, to execute transactions, and stuff like that. But it doesn't support any confidentiality. So the end-to-end encryption I was talking about before, you need to use a special JavaScript on your website to enable to wrap your MetaMask wallet that it enables the end-to-end encryption. Also, we're only talking about the EVM compatible chains. So what happens if you want to transfer, if you want to move tokens from the Paratime back to consensus layer? Well, there are some special non-EVM transactions for that, and that's why you need our wallet. So if you're doing stuff like moving tokens on consensus layer, for example, to exchanges, Binance, for example, KuCoin and some other exchanges only support receiving Rose tokens on consensus layer, so no Sapphire there. And if you have Roses on Sapphire, you first need to withdraw them to consensus layer and then move them from there to the Binance account. So yeah, this is the reason why there is a special Oasis wallet. And we have two versions of those. One is at wallet.oasis.io. That's a web wallet, basically a website, and you insert your private key or mnemonic, and then it's encrypted inside your browser state. Another wallet is a wallet extension. So it's, I think I have it installed. It's on Chrome. I won't open it right now, but you can read more about here, manage tokens, Oasis wallet, and you have the web wallet and the browser extension and instructions to install it. Also Ledger is supported and so on and so forth. So yeah, but for all intents and purposes, MetaMask is probably the right tool for you. Maybe if you just for production on the mainnet, then you want to have some access to production roses, and then you want to buy them probably on exchanges and move them to your account using this Oasis wallet. Okay. Right. The Sapphire localnet Docker. So does any one of you know the hardhat node command? Okay, some of you. So basically what the hardhat node command does is it runs mock blockchain locally on your computer. So we have this Ethereum gRPC interface, and you can connect to it. There are some pre-funded accounts called the test mnemonic accounts. And the hardhat interface usually, I can show it to you. It prints the private keys and the addresses. So the command to execute that is npx hardhat node, and this spins up it's already running. Yeah. Okay, let's try it again. It basically spins up very quickly and pre-funds 20 accounts, and then you can use those accounts locally. You can even connect your MetaMask wallet to that instance, and then when you hit the Control-C key, the chain is closed. Okay, and now there's an issue, right? We have a bunch of on-chain primitives for signing, for random number generation, encryption, decryption, and so on. This is all done on-chain. And if you are trying to do this with this hardhead built-in mock, you won't get anything. Mostly, you know, if you try to call the random number generator, you'll just have zeros all the time. And for this reason, we built a special Docker image, which contains a complete Oasis network inside the Docker image. So we have the validator node running the consensus layer, and then you have one compute node running either Sapphire or Emerald. We will be interested in Sapphire. And it prefunds some accounts, either some random accounts or the test mnemonic that are compatible with the npx hardhead node. I'm mentioning this hardhead node command all the time because the tests are usually using those accounts, and we use the same account, so you can run your tests for your dApp using our Sapphire localnet Docker image for that purpose. Right, and there's this command here on your cheat sheet. So docker run, and then there are ports you need to open. So the HTTP and WebSocket ports 8545, 8546. And I also use some debugging option. Let's remove those. We don't need that. And the URL is GitHub containers, Oasis protocol /Sapphire localnet. And you can pass, it's written here, either you can do something like 2 and your Ethereum address, and that account will be prefunded with, I think, 10,000 test tokens or something like that. Or you can just pass the test mnemonic parameter, and it will prefund the same accounts that the npx hardhead node command does. So what are we going to do next? We will hack some Solidity contracts. And for this purpose, we will spin up our Sapphire localnet image so we can use this random number generation primitives. Okay, so this will just take a minute. It takes a bit longer because we don't mock anything here. Basically, we have a 1 second, block time. I think it's 10 minutes epoch, and so it still needs to spin up the whole network and elect all the committees, spin up the key manager and stuff like that. Yeah, so this takes a minute or so, but afterwards it runs. It should run fine. Yeah. So populating accounts. Okay. Cool. So let's start on Solidity. What's my time? Okay, perfect. So 15 more minutes. So I checked out the demo star project. And the first thing I'm going to do is I will import the Sapphire contracts. So if you go to the cheat sheet, this line, import Oasis protocol Sapphire contracts. Okay, so this is the library we're going to use. And the first task I'm going to show you is random number generator. Okay. So let's, what should we do? Okay, let's compute my favorite number. So instead of calling message, let's rename this to favorite number, I suppose. And it will return the uint for this purpose. And okay. So, let's just remove the seed for now and just return sapphire.random bytes. So random bytes function will generate the x number of random bytes, so 32 bytes in our case. And I probably need to cast this to uint 256, otherwise the compiler will complain. And let's also fix the tests. So our tests currently, they call this set message. We won't be using that anymore. Also, this can go out. So the test will basically deploy our contract, and it will run this favorite number And let's print out what it produces, okay? So we can see if the random number generator really works. Okay, so the Sapphire localnet image is now spun up, and let's test our code. If we do npm test, will it compile? Okay, so it complains that oh, uint56 does not need any modifiers. Okay, and from bytes memory to tooth. So I should probably do something like this. Solidity is clumsy when it comes to casts, but yeah. Okay, so cool. The test ran, and our contract returned 0. So this smells if the random number generator is not running on our Sapphire, but on some internal hard hat node, right? And this is exactly the reason. So if you want to run the tests on the Sapphire localnet we're running, you need to pass the -- network Sapphire localnet. Okay, so this should produce something different now. Awesome, yeah. So this is the random number which was generated on chain. And if we run it again, it should be different, right? Yeah. Now, just for as a side note, the -- network takes the predefined networks in your config file. So the demo starter already has the following networks defined. So the Sapphire is the mainnet version. Sapphire testnet is the testnet RPC URL here. And then we have this Sapphire localnet, which is basically if you spin up the Docker image, this is the address. It will take the RPC address. Okay. So this is the number, the random number generator. Now, what you usually do is the following. You don't generate the random number each time, but you want to have, for example, you have some reward coupons. You gave them out to your users. You probably got the blue roses at the venue, right? So if you notice, there's this test coupon. No, it's not test, it's a production coupon. Sorry. And the QR code. And basically how the quiz is implemented is that it takes the coupon code, it combines it with some random seed, right? And then it randomizes the questions and answers for you. Okay? And now the issue is the following. You want to have, you want to have your answers and questions randomized, but per user, right? So we have, each coupon should have deterministically randomized question and answers, because otherwise, I mean, the user could, then select the answers, submit it, but then the answers would be reshuffled again, and you couldn't, match them anymore. So you want to have a, fixed randomized vector per coupon, okay? So let's do this. We want to combine the address, for example, who is signing the transaction or doing the call. We want to combine that address with some random seed. Okay. So this random part will now go inside the constructor, I suppose, and the seed will remain the same. So constructor, I don't know, seed equals this. And seed will be our private variable. So something like this. So when we deploy the contract, there will be the random seed generated, and then that seed will remain there all the time the same. And we will use it to derive then practical use cases. For example, the order of questions and answers. So in our case, let's now combine the message sender, so the address, with this seed. So we do, I think that there's an example here, right? Basically, we want to use the message and just copy and paste. So this is how the determinism is achieved. We take the message sender, we take the seed, we combine the two. Well, in Solidity, it's something like ABI.encode packed, so we can just list arbitrary number of parameters, and it will use the RLP encoding, and it will produce a long, serialized version of those. And that's basically it. And once we have this combined, yes, of course, we want to hash it. So we don't reveal the seed, right, to anyone. And then once we hash it, we just return something modulo 100, for example. And OK, let's try it out. So this should now be more deterministic. 90, OK? And if you run it again, oh, it's different. Any ideas why? OK, so when you run the test, the message box smart contract is redeployed each time. So we, computed the seed in constructor. So yeah, if we do something like this, so make then two calls to the favorite number function using the same instance, it should return the same number, right? Okay, awesome. 59, 59, cool. By the way, the n thing here is because it's a big number. This is JavaScript specifics. Don't bother. Okay, cool. The next task. Let's generate the signing key pair. Question. Okay. So 4 minutes, including questions.
You have until 16:23:24.
Okay. So let me just do another short example. So I want to generate the key pair on chain. So something like this. Oops. Where's my Solidity contract? So this example is pretty cool. So that's why I wanted to show it to you. So basically, we will generate a signing key pair based on our seed. And then we will use this key pair to create an Ethereum transaction that can be, broadcast. Gasless DX. So yeah, you already see from the name of the variable what's the point of everything. So the Sapphire library also provides something called EIP155 signer. That's basically a shortcut to generate Ethereum transaction on chain and sign it with the provided key. The key is a 32-byte secret part and 32-byte public part, and the address also needs to correspond. The address is derived from the public key, and the public key must match the secret key in order for the signature to work, right? Okay, so what do we do? Let's take the address. Let's take one of these addresses. Suppose this account 070 will be the one who pays for the gas. The secret key is this one. And then the transaction content will be something like we need a nonce, and then to define the gas price, the gas limit. So standard Ethereum transaction. And now what will the transaction do? Well, we will call a method inside our smart contract. Which method? Let's say set message. What parameter? My message. Okay. And what else? Well, yeah. Suppose this is fine. Maybe the test still needs some love. I'm not sure if this works. Okay. Yeah. Let's skip the key generation for now. Oh, yeah, this should be another Solidity specifics. And 29 line is which one? Oh, nonce is 64 byte. I didn't know that. Cool. Oh, let's output the. What's the output? Yeah. So let's console log. Where did it go? Console log favorite number. So now that we re-implemented the favorite number, and it should output the Ethereum transaction we can broadcast. Now, the whole idea is that you generate transaction online using this public key address and the secret key. It can be stored, suppose this is stored in a contract and no one can see it except for example, the owner of the contract. And it can generate and sign transactions completely on chain. So if you look at the transaction now and check if it's really an Ethereum transaction, we can go to the Ethereum transaction decoder, something like this, and try to see what's inside. And we can see it's a perfectly valid Ethereum transaction. There's the gas limit, gas price, nonce, destination address, data, and data includes the function the transaction calls and the parameters. So if you were there and just then use the client to submit that transaction, it will work. And that's the exactly same mechanism we used in this ETHDam quiz you got when you got your blue roses to receive your tokens. So we have some other account paying the gas fee for you, and you just need to type in the receiver address for the tokens. You don't need to have a MetaMask wallet connected to our dApp or whatever. Okay, so this is just an idea for any developers out there for the hackathoners who want to decouple the current Web3 MetaMask-ish tooling away from the actual blockchain that's used behind the scenes as a backbone, for example. Okay, cool. This is it from me. Thank you. Good luck.
Questions? Oh yeah, some hands.
I had a quick question. In the constructor on the random generation, there was an empty string as one of the parameters. Yeah, what's that for?
This is the extra entropy. So suppose you want to initiate the random seed using some function, some transaction, not inside the constructor, but also want to provide some extra entropy if you don't trust the on-chain enclave.
Thanks.
Mm-hmm.
So you got to my question. So this was originally a question about, is this possible or not? Because we want to use a third-party tool, which itself needs, it has like a subset of JavaScript, so itself needs to wrap the transaction that it makes to an EVM. So I was hoping that we could just make that straight to Sapphire by putting the RPC endpoint of Sapphire in. But maybe we can't, because you're saying that you need some JavaScript to wrap the actual transactions to Sapphire, because it's not fully equivalent to the EVM when you make that call. But now I'm thinking, you've just demonstrated wrapping a call to an actual EVM in Sapphire. Does that mean that we could we could use Sapphire to sign a transaction to another EVM. So we could somehow call Sapphire via, whatever simple endpoint, and then use that to wrap a transaction to another EVM.
Okay, so if you want to use bridge, we have this Oasis privacy layer OPL called, which integrates the seller bridge library, and it already supports sending messages back and forth a number of chains. Another thing, Sapphire is you can use ordinary non-encrypted standard EVM transactions to Sapphire, and they will work fine, but they won't be encrypted. Okay, so it's up to you to use end-to-end encryption or not. It's totally up to you. So you can just, as you said, switch RPC, and it should work. The contract should be deployed, and it should work out of the box. Well, not that much, but yeah. I mean, the whole bounty idea is that you use the Sapphire primitive, the Solidity Sapphire primitives as much as you can, to make something useful on chain.
Amazing. Thank you so much. Unfortunately, that's all we've got time for on questions. If you've got more questions for Oasis, they have
I'll
nice
be there,
big
and
booth.
also on Discord channel.
Yeah, they have the booth downstairs. Please go and interact with the sponsors. That's why they're here. They want to speak to you. They want to hear your questions. Thank you so much for your time. That was excellent.
Yeah, thanks. Yeah.